Hey, this is Mr. Beckstrom, and today I wanted to take a look at a little bit in section 2.4, and this is basically dealing with a piecewise function. We want to see how to find the domain, the range, the intercepts, and we also want to see how to graph this thing. So normally I like to put this in my graphing calculator, and we can still do that, and there's videos on how to do that, and I will post some of those. But I just wanted to do this one purely by hand, just because the TI series is not great at doing piecewise functions, although you can kind of trick it into doing it. But let's concentrate on kind of just doing this one by hand. So the first thing is, what is the domain of f? This is, what are all the x values I can put into this function? Well, notice this is broken up into three different functions depending on whether x is between -2 and +2, where x is 2, and where x is greater than 2. So it looks like x is defined for everything greater than -2. Now, are there any other restrictions over here? That means, are there any other ratios or square roots or anything else that we have to deal with? No. So that's going to be our domain. So for A, put this in, and I'll do this in interval notation. We do include -2 because it is included in there. So we're going to do the bracket -2, and this goes all the way to +infinity. And if you're having trouble conceptualizing this, another thing you can do is, just set yourself up a number line. This will be for my x values. We see that put this at 0, so we have values between -2 and +2. We have values at 2 and greater. So then if I just go through here and mark where I have values, I'll see that I'll have them everywhere from -2 and greater. That's why this is the domain of my graph. All right, B, we want to locate any intercepts. Locate any intercepts. So to do this, I have to look at all three of these functions, see where I might have intercepts for those functions, and then see if those x values are in my domain here. So for the first one, I'm going to set -x minus 1 is equal to 0. Add 1 to both sides. I'm going to get -x is equal to 1, or x is equal to -1. So is -1 in my domain? Is it between -2 and +2? It sure is. So this is going to be one of my x-intercepts right here. I'll just kind of put a circle around it. The next one, I look at the second function, 3. Well, that's kind of weird. In this case, 3 is never equal to 0, right? So we don't have any x-intercepts for this. Y is equal to 3 is just a horizontal line that goes through the y equals 3 here, right? And then 2x squared, that's the last one we have to take a look at. Well, I should have put that equal to 0. And this is never equal to 0, so 2x squared equal to 0. So divide both sides by 2, and I have x squared is equal to 0, and x is equal to 0 if I take the square root of both sides. So 0 is the only value that makes the function equal to 0, and that is not greater than 2, so this is not part of our x-intercept. So we only actually have 1, which is at -1. So -1, 0 is going to be an x-intercept, and I'm going to go ahead and just put that right here on my graph. The C question is to graph this thing. So to graph this thing, I'm going to do it in parts. So I like to do dotted lines. I'm going to do it in kind of a different color here. So the first one goes from -2 to +2. So I'm going to go to my x where I have -2, just draw a vertical line like this. It just helps me kind of graph this. And then I'm going to draw another one at +2. And excuse my dotted lines, it's a little bit weird on this program. All right. And then that's it. I don't have any other breaks. So I should have a function between these two horizontal lines, I should have a function, the middle one, right somewhere on this dotted line, and then I should have a function to the right of this dotted line. So if I break it up, I'm really breaking it up into 1, 2, 3 different parts. And remember, there's nothing where x is less than -2. So we're fine there. All right, so let's graph this thing. So the first one between here and here, I have this function here. So I'm just going to write that out right here. So now let me go ahead and change pens again. So y is equal to -x minus 1. And if we know this is in y-intercept form, so that means our y-intercept is at -1. So I have a point right here at -1. And then this is a negative slope. So that means it goes from upper left to lower right. And we can write that slope as, well, we can write it as a couple of ways, but I'll write it as -1/1. And that means it's going down 1 and over to the right 1. Or it can also go, you could read that as, remember, the rise over run. Or you could put the negative on the bottom and it can go up 1 and to the left. So I'll do it. So up 1 and to the left, sure enough, that was a point. And I have a point here. It includes it, so we're going to do a closed circle on that red dotted line, and then we're going to go down here, and when we get to this value here, we notice that this is not a strict equality. Excuse me, it is a strict equality, so we don't include it. So down here, I'm going to draw an open circle at that point. And then I just connect the line as straight as I can, and I get something like this. Now I say, all right, well, this deals with the first part. How about the second part? Well, the second part is just y is equal to 3. And it's only when x is equal to 2. So if I go to x equal 2, y equal 3, I have a point all the way up here. So it goes down here, and then once it gets to x equals 2, it jumps up to 2, 3. And then past 2 to the right, I'm going to use this function here. So y is equal to 2x cubed. And for this, I'm going to do myself, and I know I'm kind of getting a little bit messy here, but I'm going to do myself a nice little, try to do a straight table. It's as straight as I'm going to get. X and y, just to see the behavior of this. My x's start at 2 here, so I'll start at 2, but remember it doesn't include that, so I'm going to have to start with an open circle. And let's just do a couple of more values to see what's going on here. 4, 5. So at 2, we plug that into the function there, or this function here. That's 2 cubed, which is 8. 8 times 2 is 16, so I have a pretty high y value. And then at 3, that's actually going to even be off the graph, isn't it? So it's going to be somewhere way up here, and it's going to jump up pretty high. 3 cubed, 3 times 3 is 9, 9 times 3 is 27, 27 times 2 is 54. And as you can see, we're going to jump up really fast here. 16 times 4 is 64, times 128. And 5 cubed is 125, times 2 is 250. So it starts at 216, which is up here. Remember, open circle. And then it's going to kind of look like this all the way up there. It's going to be a very steep curve going up this way. All right, and then the last thing it says is use the graph to find the range of f. So these are all the y values of f. So notice we have no y values that are less than -3 here. So if we were to start, we're actually going to start, and we don't actually even include that -3. We're just looking at y value. So you start from -infinity, you're moving your way up. The first y value that you find is right at -3, but not included. So it's going to look like this. And it's going to go all the way up until the y value of 1. Up. Do we include the 1? Yes, we do. So that would be a bracket here. and then we're going to join it with the next one, and it looks like we have a point at 3 here, a y value. So this is just going to go from, this is going to include 3, so we go from 3, looks a little bit weird, it just means that we're using the point 3, and we're going to go up, and then the next one is until we get to the y value of 16, and that'll go up to positive infinity, and we are not including 16. So from 16 all the way up to positive infinity. All right. Well, there you go. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.